Okay, this is CIN2103, week 9, module 12, IP version 6. Okay, addressing. Now we know that IP version 4 is 32-bit, IP version 6 is 128-bit. Okay. They developed IP version 6 because they were worried that IP version 4 will run out of addresses, and there were some problems with IP version 4, some limitations. Okay, because now we have more people are using the internet, IoT devices. Also because of the issues with NAT, you know, with IP version 4, you need to use NAT for your subnetting in order to reach to the outside to the internet. Okay, so it is better, more practical to move into IP version 6, and it's gradually being moved. It's being moved. Okay. IP version 4 and IP version 6, it's not like, okay, IP version 4 will disappear and IP version 6 will start tomorrow. They will live together for some time. They will live together for some time. This is how technology. You don't just drop Windows and then use Mac or like that, or Windows version, Windows 10, and you know, they coexist. Okay? So, IETF, the governing body, created various protocols and tools to help network administrators migrate their network to IP version 6. These migration techniques can be divided into 3 categories. The dual stack. The devices run both IP version 4 and IP version 6 protocol stacks simultaneously. So they are running both. You cannot, sorry? The PowerPoint? Okay, just hold on, let me check. Okay. I will upload it again to BBLearn. Maybe this will solve the problem. Okay. So create, add, edit. All right. So I will add the file one more time. Can you check now, please? This should work, okay? The second category is, so we have dual stack, both running simultaneously. Then we have tunneling. So it's a method of transporting an IP version 6 packet over an IP version 4 network. So I have IP version 4 network I want to transport IP version 6 inside that network. I do tunneling. Okay? So the IP version 6 packet is encapsulated inside the IP version 4 packet. The third one is translation. Here we use NAT64. Okay, allows IP version 6 enabled devices to communicate with IP version 4 enabled devices using a translation technique similar to NAT for IP version 4. Now, tunneling and translation are for transitioning to native IP version 6, and they are only used when needed. The ultimate goal is to have IP version 6 everywhere. Okay? Of course, IP version 6 is not case sensitive when you write the letters. This is the preferred format, Shabab, for writing the IP version 6. Okay? You use semicolon in the middle. So you are putting X or hexadecimal numbers. So you have 4 by 4, 4 plus 4 plus 4 plus 4. Okay. IP version 6, a hextext is the unofficial term used to refer to a segment of 16 bits or 4 hexadecimal values. Yani each part here, they call it hextext. It's an official term. These are examples of IP version 6 addresses. Each of these numbers is hexadecimal number, Shabab. So this 2 is actually hexadecimal. This is 4 bits. Okay. Eight times 8 times 4, 32, times 4, 128. This is how it's calculated, all right? Okay, now there are some rules for writing or describing the IP version 6 address. The first rule is to omit any leading zeros, any leading zeros. So if I have 01 AB, khalas, because the 0 is on the left. 1 AB, 9 FO, okay? 0A00, 0A, it will become A00, okay? That's very simple. The rule only applies to leading zeros, not to trailing zeros. Otherwise, the address would be ambiguous, of course. Only to the leading zero. Okay? So here, if I have this, both are correct, but this is preferred. 2001, 0 DB8, I can remove the 0. You see here, 4 zeros, only 1 0. 4 ones, 4 ones, don't write 1. Only zeros, 4 zeros can be 0. Okay, 0 0 0 0 0 200 200. Any question? A double colon can, so instead of only 1 colon, it has double colon, can replace any single contiguous string of 1 or more 16-bit hextext consisting of all zeros. We'll give you one example. Here I have this number here. You see here I have 0, colon 0, colon 0. What we can do for the last part, we can put 1 double colon 1. Okay? This is also another abbreviation. The double colon can only be used one time you can use it within an address. Otherwise, there would be more than one possible resulting address. So here we have one example. These zeros plus zeros plus zeros. Instead of them, we just put double colon. Alas. Okay, but I can only use it once.
Sorry.
Yeah, abbreviation for writing. Simply address presentation, representation rules. Okay, now just hold on. It's uploading the file. This is the file that I emailed, that I uploaded for you in the portal. Fixed time. Oh, it's taking time. Okay. This is the updated PowerPoint. They removed like 5 slides, okay? So it's simpler, it's smaller. We already mentioned this, that IP version 4 is running of addresses. There is problems with NAT, okay? That's why the agencies or the institutes who are managing the internet decided to introduce IP version 6. This already we mentioned. The coexistent already explained. This is the format, we have already explained that. Okay, so no changes to these slides. Okay, Unicast, Multicast, and Anycast in IP version 6. Same like IP version 4, Unicast uniquely identifies an interface on IP version 6 enabled device. So you are sending to one device, one interface. Multicast is used to send a single IP version 6 packet to multiple destinations. Now in IP version 6 we have something called Anycast. We did not have this in IP version 4. Anycast, this is an IP version 6 unicast address that can be assigned to multiple devices. So a packet sent to an Anycast address is routed to the nearest device having that address. Okay, so that's the meaning of Anycast. Alaikum salam. Specialized for IP version 6. Anycast. If a packet receives this Anycast, it will forward it to the nearest device that have this Anycast address also. This is good for some routing, some networking management, by the way. Unlike IP version 4 and IP version 6 does not have a broadcast address, if you notice. However, there is an IP version 6 all nodes multicast address that essentially gives the same result. So instead of broadcast in IP version 6, we have IP version 6 all nodes multicast. So if you choose multicast with all nodes, it's like broadcast. Prefix. Remember in IP version 4 we said prefix /8/16/24. Same thing. Prefix length is represented in slash notation and is used to indicate the network portion of the IP version 6 address. The IP version 6 prefix length can range from 0 to 128. And the recommended length for LANs and most other types of network is /64 because we have plenty of addresses. MashaAllah. So /64. So here I have my prefix is 64. Okay. And my interface ID is 64-bit. All right. Here we have an example. So the first 4 hextet, this is your prefix, and the other 4 hextet is your interface ID for this network. Look at this example. 201 DB8 0, and because I have double colon, then it is all zeros. Okay, you got it? How they get this number? Please, you might get question like this. Because I have double colon at the end, this means all zero. Okay. It is strongly recommended to use 64-bit interface ID for most networks. This is because stateless address auto configuration or SLAC uses 64-bit for the interface ID. It also makes subnetting easier to create and manage. So let's stick to this rule. 64-bit interface ID. But we are not going to do any subnetting for IP version 6 in this course. Okay. Types of IP version 6 unicast addresses. You remember in IP version 4 we have only one unicast. But here we have 2 unicast addresses. We have a global unicast address, GUA, and this is similar to a public IP version 4 address. So these are globally unique internet routable addresses. This is global unicast address. Then we have link local address, LLA. It is required for every IP version 6 enabled device and used to communicate with other devices on the same local link. This is not routable. It's private. It's only local, link local address for the devices inside the same network to communicate with each other. It will not go to the router. IP version 6 GUA. The global routing prefix is the prefix or network portion of the address, like slash, you know, when we used it. Okay. It is assigned by the provider, such as the telecom company, okay, or the internet company, to the customer or site. Okay. And the global routing prefix will vary depending on ISP policies, according to the policy, to the country, to the geographical location. All right. You see here, this is a global routing prefix. The first 3 bits on the left, these are 0, 0, 1. So the range of the first hextet will be from this number to this number, from 2000 to 3FFF. This will be the range for the IP addresses in IP version 6 for the GUA. Subnet ID, the subnet ID field is the area between the global routing prefix and the interface ID. Here, this one. I have my interface ID here. This is my global routing prefix. The subnet ID is used by an organization to identify subnets within its site. This is how they designed IPv6. The subnet ID field is the area between, already we mentioned this, interface ID. Remember the interface ID there, we used to say host ID. Interface ID is equivalent to the host portion of IPv4. It is strongly recommended that in most cases 64 subnet should be used, which creates a 64-bit interface ID for simplicity. Don't make it hard on yourself as an administrator. All right? So the interface ID is 64-bit. The link local address enables a device to communicate with other IPv6 on the same link here, as you can see here. This router talks to this router locally using LLA. Okay, this router talks to this computer using the router interface using LLA. Okay. What is the, please, what is the gateway for this computer? It will be the LLA address of this interface, like Mac. You remember the Mac? So what is the default? What is the default gateway for this computer to reach to the world? You only see this router, like the door, gateway. And how can I open this router? I need the LLA address, the local address. It's written here. So this is really important, okay, to understand IPv6 operation. Does these videos open? Have you ever tried them? Someone told me they don't open. I thought only on my computer they don't open. Yeah. Why? All right. Static GUA configuration on a router. Most of the commands are the same format. You only need to put maybe 6 sometimes. So if I want to give an interface IP address, first I will call the interface, same command, interface, and I put the interface name, and then I will type, instead of IP, I will type IPv6 address, so and so. Okay, and no shutdown and exit. All right. You can do static GUA configuration on a Windows host manually, same like how you configure your IPv4. Okay, it's similar to IPv4. For the default gateway, it will be the LLA address of the router. Here, this part. Yes. LLA is link local address. No. Okay. When you are using DHCP or Slack, the LLA of the router will automatically be specified as the default gateway address. Of course, if you configure it in the DHCP. Remember when we configured DHCP we need to put some information in CIN2003 course. We put the default gateway, the DNS. Static GUA configuration of a link local unicast address. So you can configure the LLA manually, and this lets you create an address that is recognizable and easier to remember. LLA can be configured manually using IPv6 address, and we call it, and this is the command, IPv6 link local address and link local command here. You see the command IPv6 address and then link local at the end, all right? And no shutdown. The same LLA can be configured on each link as long as it is unique on that link. Common practice is to create a different LLA on each interface, of course, of the router to make it easy to identify, obvious. Otherwise, we get confused. How do I know which interface is this? We have also some other messages for dynamic. Now, we just talked about static addressing, and manual addressing. Now, we have dynamic addressing. We have two types of messages. And the devices, they obtain their addresses dynamically through Internet Control Message Protocol, which is ICMP version 6. We have two types of messages. RS, which is router solicitation. They are sent by the host devices to discover IPv6 routers. Router solicitation, and they want to know where is the IPv6 routers. The host send this message because they want to know where are the routers here. Okay, who's the boss? And then we have router advertisement. This is sent by the router to inform host on how to obtain an IPv6 GUA and provide useful network information, such as network prefix, default gateway, okay, and so on. The router advertisement can provide three methods for configuring IPv6 GUA, either Slack or Slack with stateless, the ICP version 6 server, or stateful, the ICP version 6. If we say stateful, meaning that there is no Slack. Okay. This is the method here. So this is Slack. Slack allows a device to configure a GUA without the services of the DHCP. So here we have the ICMP version 6 router advertisement. It goes to the host. This is the router advertisement message. It has the prefix. Okay, and this is the interface ID created by client device. All right. So you can see here that ICMP helps to configure, helps to provide the information to the hosts. Okay. It provides the information to the host to configure its address. The prefix is also provided by the RA, router advertisement. The router is the boss. And the devices uses either EUI 64 or random generation method to create an interface IP. Okay. This is the Slack. Here we have the Slack and stateless DHCP. A router advertisement can instruct a device or host to use both Slack and stateless DHCP. And this is how it will go. Slack, you will need the Slack to create its own IPv6 GUA, and then to create the router to identify the router LLA, link local address, okay, which is the router advertisement source IPv6 address. So when I receive the advertisement and I am using the ICMP, I know that okay, this is the router IPv6 address. Then I will use it as my LLA, okay, as my default gateway, because I know this is my router. The router told me I am the router, I am the boss, I am the gateway. A stateless DHCP server to obtain other information such as the DNS and a domain name, also done in this method. Stateful DHCP, and here we are not using the Slack. Here the router advertisement can instruct a device to use a stateful DHCP, only by DHCP. So DHCP will provide everything, like in IPv4. It will provide the address, provide the DNS, provide the gateway, okay? So the router LLA, which is the RA source IPv6 for that device. So the last one is very similar to the IPv4 when you use the DHCP. Any questions, Shabab, about this? For the dynamic addressing of IPv6 also, there is a process defined by IEEE and EUI organizations. Here we have, what does this process do? It will insert a 16-bit value, yani 4 hexadecimals, okay, inserted into the middle of the 48-bit MAC address of the client. You know your MAC address, they will insert into it a 4 bits, 4 hexadecimal number, okay? And the 7th bit of the client MAC address is reversed from binary 0 to 1. Yani look here, please. This is the original 48-bit MAC address that we have before. They will insert this value, FFFE. شايفها? Can you see it? All right. And the 7th bit of the client MAC address is reversed from 0 to 1. Here, FC, if you remember, FC is equal to what? 4, 8. 12. A is 10, B is 11, C is 12. يعني إيش؟ 0 1 sorry 0 0 1 0 1. Okay. 0 1 sorry 0 0 1 0 1. Sorry 0 0 1 1 12. Now if I reverse the 7th bit of the MAC address, this C will become E. You can write it, convert this number and do it, you will get this number. All right. So this is the AUI 64 process. They insert a 4-digit hexadecimal number, FFE, FFFE, and they reverse the 7th bit of the client MAC address. The first one on the left. Yeah. Only this one is reversed. The one in red color. E. See the E? You got it? So the original address is this one. Now it becomes this one. We convert the bit, the binary. مش the hexa, the binary. We have also randomly generated interface IDs. So depending upon the operating system, a device may use randomly generated interface ID instead of using MAC address and the AU64 process. If you remember, when you start your Windows, if you don't have any DHCP, you are not connected to the internet, you did not put a static IP address, your computer will use an IP address that's only temporarily just to get booted, to get started. And with Windows, the old way was there is a randomly generated interface ID. Okay. So if you look here, if you type ipconfig, you will get these IP addresses. All right. We have the IP version 6 address, link local IP version 6 address, it's different. And we have the default gateway. Now, to ensure the uniqueness of any IP version 6 unicast address, the client may use a process known as duplicate address detection, DAD, DAD. This is similar to an ARP request for its own address. If there is no reply, then the address is unique. Remember, we use ARP, you give the IP address, it will give you the MAC address. So also the device, to make sure that its address is unique, it will use that. It will put the address. If it receives response, this means that someone is having this address. If there is no response, then it's unique. So that is similar to ARP. Dynamic link local addresses. All IP version 6 interfaces must have LLA. LLA can be configured dynamically as well. Okay, here, this is dynamically created using the FE80:10 prefix and the interface ID using AUI64 process or randomly generated 64 number. And we have already studied the AUI64 process here. Okay. So this will automatically, for each interface, we insert these numbers, we reverse the 7th bit, and then you have your dynamically created LLA. Dynamic LLAs on Windows, again also, Windows will typically use the same method for both a Slack created GUA and dynamically assigned LLA. You can check it using your ipconfig command. Okay, we will try it. Can you please try your ipconfig and see your addresses on your computer? I type ipconfig. This is my link local address. You see here, link local address. And this is my, it depends on how many interface cards in this network, all right? Dynamic LLAs on Cisco routers. Also, the routers create automatically an IPv6 LLA whenever a GUA is assigned to the interface. And Cisco, by the way, also uses EUI64, okay, to generate the interface ID. It's a common agreed process for all LLAs on IPv6 interfaces. Otherwise, it will be very hard. And it will be complicated. That's why they try to automate it, dynamically assign it. Here is an example of LLA dynamically configured on a Giga Ethernet interface on router. If I type the command show interface Giga Ethernet 0/0, then it will show me the IP addresses. You can see, I don't know, you can see, is it clear? Yeah, you can see it here. You maximize it. Yeah, I think the color maybe is, you see here. Yes. Yeah, sorry. Yeah. So this is your hardware address. Now this is your interface address. And you see, you can see part of it is the same. Yani part of the numbers used is the same. I don't know why it's not clear. I can see it, but I have to look very close. All right. So here we have 7279 colon B3 FF colon FE and then 92. And if you look here, you have 7079 B392. Okay. So the router uses, and what we need to know is the router also uses the EUI64 to generate the interface ID. How do I verify my IPv6 address configuration? We can use show interface. We will do some show interface in the lab, even for IPv4. Assigned IPv6 multicast addresses. IPv6 multicast addresses has a prefix. This is the prefix for IPv6 multicast. And there are two types of multicast, well-known and solicited node multicast addresses. And multicast addresses can only be destination addresses and not source addresses, of course. Multicast is to the destination, not a group of people sending at the same time. There is no multicast from source. Okay? Even with IPv4. These are the Two common types of IPv6 assigned multicast groups. FF02:1, all nodes multicast group. Okay. Similar to broadcast, صح? And then we have FF02:2, all routers multicast group. Here, a router becomes a member of this group enabled as an IPv6 router. Okay. This information needed for the routers when they are doing the dynamic updates of the routing table. Subnet using subnet ID. So IPv6, when they designed it, they were also thinking about subnet. So a separate subnet ID field in the IPv6 is used to create a subnet. The subnet ID field is the area between the global routing prefix and the interface. We have already mentioned this before. This is your subnet ID. Okay, they are repeating. Okay, it's between your the global routing prefix and your interface ID. So you have 48 plus 16 plus 64, 128. Please remember how many bits is it, okay? This is example. And if you have here a 16-bit subnet ID, it allows 65,000. You can use your calculator to calculate this, to check the numbers. The global routing prefix is the same for all subnets, of course. Only the subnet ID hexbit is incremented in hexadecimal for each subnet. Okay, so this is an IPv6 subnetting example. Any questions? IPv6 subnet allocation. Here we need to create 5 subnets, one for each LAN as well as for the serial link between, for the one link here. Okay, so I need 1, 2, 3, 4. Okay, plus here this one link, the red one. Then I need 5 subnets. So these are allocated using IPv6, and the subnet ID field from 001 through to 0005. Okay, each /64 subnet will provide more addresses than will ever be needed, of course. Okay, yani what we have done here, look here, please. For the subnet ID, I will put 001, 002, 003, 004, because we have a lot of addresses. The IPv6, you have, it is enough for everyone, everything. Okay, go back here. Here it shows you the configuration on one of the interfaces of the router. You call the interface, you give the IPv6 address, no shutdown, and then you configure the second interface and the third one, and no shutdown. That's it for this chapter. Do you have any question?